so let's look at 5. First thing I would want you to identify any holes in the graph. There are no holes. Any questions about that? Next thing, x-intercept.
1, 0.
At 1, 0. Any other x-intercepts?
Oh, this is the
0, 0.
I think 0, 0. No?
Nope, that's the only one. 1, 0 is the only x-intercept. Look, so I know why you put 0, 0. Because there was a number in front. Is that why?
It doesn't have.
There is no x. That's exactly correct.
That's why.
So that's why there is not one at 0, 0. No. No, you have to go. You can go to that teacher's lounge bathroom. They got favoritism in there.
There's a bathroom in there?
There's 2.
I'm sorry, is this the teacher's lounge? This is the AED?
Yes. We can shock your heart.
I'm certified to use it.
Me too.
Wait,
This year, then I won't be next year. So
I'm certified this year
Yeah.
and next year, and I won't be certified next
if you're gonna get recertified, then you're certified for 2 years.
I'm
So
certified this summer.
okay, I get you. So you got all this year and next. So there are no other x-intercepts, but this x-intercept has a multiplicity of 2. And it's going to bounce. Okay. Vertical asymptote.
X equals -1.
It's not -1. -5.
Because it's in the bottom.
The denominator. Right, set the denominator equal to 0. So x plus 5 equals 0.
X minus 5 equals 0.
X plus 5 equals 0. And solve. And now what do we know about this vertical asymptote? It's going to have togetherness.
What does that mean?
That means when I draw my vertical asymptote, it's on either side, they're either going to both go up or they're going to both go down. I have togetherness at the vertical asymptote.
How can you tell?
Because the multiplicity of that factor is even.
If it's even, it's going to have together.
That's correct.
So this is a degree 2 polynomial?
It's not a polynomial.
What is it?
It's a rational function. The polynomial in the numerator is degree 2, and the polynomial in the denominator is degree 2. So because the degree of the numerator is equal to the degree of the denominator, then I have a horizontal asymptote at y equals
0.
-3.
Oh, because there's a -3 at the front.
So if you're struggling with doing it when it's in factored form like this, then you're going to need to distribute it. Right? So this is x minus 1 times x minus 1. That would be x squared minus 2x plus 1 times -3. And so the numerator is going to be -3x squared plus 6x minus 3. And then the denominator is going to be x squared plus 10x plus 25. That's distribute it at. Now can you clearly see the horizontal asymptote is at y equals -3? So if that's something that you need to do, you may need to make sure you distribute it all the way out. It also makes it easier to identify the y-intercept.
The y-intercept would be around.
It's at -3 over 25. Or -0.12. The constant in the numerator over the constant in the denominator.
But there's no constant.
There is.
Where? Oh.
-3.
25. Is it 25?
And 25?
Oh.
What do you think that said?
So you can just take.
Well, I was thinking it wasn't a constant because it's inside of the parentheses.
But after you do the
If you
exponent, it's
distribute it,
not
that's
good.
correct. Okay, and then last thing we got to check, does it cross? Well, I don't know. Let's see. I'm looking for where the horizontal asymptote is at, which is -3. So I can say -3 equals -3x squared plus 6x minus 3 over x squared plus 10x plus 25. Put that over 1. Cross multiply. And so that's going to give me -3x squared plus 6x minus 3 equals -3x squared minus 30x minus 75. So these are going to cancel. When I move this over, it's going to give me 36x. And when I move this over, that's going to be -75 plus 3, which is -72.
Oh,
Solving that out, I get x equals -2. So yes, it does cross. It crosses at -2, -3.
So I have a question.
Yep.
You said that like the packet you gave us on the first day of school was for
Until Christmas.
until Christmas, right? We're almost done with it.
Mm-hmm.
We're gonna finish way before Christmas.
Yeah, we're going to finish the packet before Thanksgiving.
Oh.
And then after Thanksgiving, we're going to do a packets, or we have to do those handouts from Northeast, where I teach you individual Northeast lessons.
we are not almost done yet.
No, I'm talking about we are almost done with the packet.
No,
We've done a lot.
We've done way over half.
Yeah, we've done a lot.
No.
X-intercept is at 1, 0.
This is what we've done. This is what we've done.
Y-intercept is at 0, -3 25ths, which is just almost 0.
It's like,
Look right there. I have a vertical asymptote at x equals -5. I have a horizontal asymptote at y equals -3. Then I also found out at -2, -3, it crosses the horizontal asymptote. So at -2, -3, it's going to cross. And what else am I forgetting? Horizontal asymptote at negative, I've already done that. X-intercept, vertical asymptote, horizontal asymptote, y-intercept, that's everything. Okay, so we also know at this x-intercept it bounces, right? So let's go to the right side. The right side's it's a little confusing, right? Because there's a horizontal asymptote there, but I've got to cross it, and I've got to get to the vertical asymptote. Or would you guys rather do the left side first? Which one do you feel better about? Don't know? You don't feel good about any of it? So we know it's 2 pieces, right? Because there's one vertical asymptote. Let's see, if I have to be here and I have to bounce, right, is it ever going to cross the x-axis again? No. So what's it going to do as the x's get really big? It's going to decrease and get closer and closer to the horizontal asymptote, which is -3. So it's going to do that. All right, and now what do I know? I know at -2 I have to cross this horizontal asymptote. So I'm going to go somewhere here. Does it ever cross it again? No. So as I approach the vertical asymptote, it's going to go down like that.
how does or horizontal asymptote cross? How does an asymptote?
What is the purpose of a horizontal asymptote?
Closer
To a thing.
As the x's get really, really big or the x's get really, really small, it tells what the y values approach. That's the only purpose of a horizontal asymptote. In the middle, or the meat of my graph, it does other randomness where it can cross a horizontal asymptote. Horizontal asymptotes are designed to tell us what it does when the x's get big and the x's get small.
Technically, Miss Ferguson said it doesn't. It doesn't touch that point.
It can never cross a vertical asymptote. Never, 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 never. Because vertical asymptotes come from the denominator, which is a divide by zero error, which you can never do. But the horizontal asymptote is not something that's an error. It's just something that the graph approaches as we get really large x and y values. Because remember, we talked about what's the dominating term? It's the x squared in the numerator and denominator. And so if I just compare the dominating terms, negative 3x squared over x squared, well, just think, if the other terms don't matter, if I plug in 1,000,000 for x, well, 1,000,000 squared is, I don't know, a lot. Well, a lot times negative 3 is negative 3 times a lot. Well, if I put 1,000,000 in the denominator for x squared, what's 1,000,000 squared? A lot. So those terms, the a lot over the a lot, cancels, and you're left with negative 3, essentially, because we're really close to negative 3 at the 1,000,000. Does that make any sense? I'm trying.
1,000,000 squared of Google.
No.
That's a browser.
No. A Google is 1 followed by 100.
Googleplex is
1 followed by Google zeros. Let's don't get there right now. We got enough problems. We don't need to go there at this point.
Can we Googleplex square?
Yeah,
Okay.
you can do that. You can square any number, Cameron.
That's a big number, isn't it?
Pretty big. Googleplex is pretty big. On the left side of the vertical asymptote, do I know any points?
I think about 100.
No, so then that tells me I know what it's going to do. It could be on the bottom and look something like that. That gives me the togetherness that I was expecting. Right? It also does not cross the horizontal asymptote, which is not allowed, and I have no x-intercepts. So that has to be where it goes. We can check it by putting it in our graphing calculator. You guys want to do that just to see how much we know or how little we know? Y equals fraction. Negative 3 parentheses x minus 1. Close parentheses, square that. Over parentheses x plus 5. Close parentheses, square it. And then zoom 6.
Is this going to be one of them on the test where you can use the calculator?
No. You won't be able to use a calculator on this.
What?
No, you won't be able to use a calculator on the test at all, I don't think.
We don't get a calculator at all on the Unit 1 test.
Unit 1.
What are you asking about? Why are you saying Unit 1 test? Unit 1, yeah, you get a calculator.
The whole test?
Unit 1, yeah, it's a Northeast test. Alright, so when I look at mine, I've only got one piece of this. Is that the way y'all's looks? I can't see what's happening on the left side. So I'm going to click zoom, zoom out, enter. And as I zoom out, I see the shape. You probably typed yours in wrong, Colin. Your equation.
What's the equation? No, I thought. Is it that right there? That's a red X there.
I mean, the stuff that I try to teach you guys and the questions that you have is not match the level of
Oh.
f of x equals negative 3 parentheses x minus 1 squared over x plus 5 squared. Or you can do that other one that I wrote in black at the top after I distributed it. They'll both be the exact same.
Then I'm just gonna do the one that's
It's already what?
They're both already right.
I think that I would write the one that they gave me in case it's shorter and in case I made an error. in my distributing.
Whoa.
I trust that you do not
It
think
tries to act like it's gonna do a vertical asymptote, and then it goes back down.
Well, it depends on what you look at it from.
What? That confused me.
Like it's gonna act like it's gonna get there, and then it just starts going down after.
What?
Oh, do we have the same one?
So this one? Did we get it wrong? This one?
Did we get it wrong?
It's not going down to that -3.
It is. Yeah, it is.
Oh, because it's starting to go down right there.
Yeah, we're just zoomed out so much that you can't tell it's -3. If you go second table and you look at these values, what are the y's getting closer and closer to? Well, I know that these are ugly fractions. You don't know what it is, but like if I do, let me show you. If I go mode, if I turn it where I take off fractions, which would be here, I can make answers be decimals and then go to the table.
Less than -3.
Years ago. Forever and ever and ever.
Wait, go to mode. What do we do?
Nothing. Don't do that. You know what? You do all kinds of stuff.
You can play games on this.
I know, I said imaginary numbers on my VCT.
Dude, my calculator had some mode. It was like ACT something.
ACT help or something?
Yeah, that.
Okay, now I'm going to work this one just because I want you guys to see how fast you really need to be able to do it. I'm going to talk as I'm doing it, so I will not be working it as fast as I can. All right, but I'm going to tell you what I'm thinking as I'm doing this. First thing, the denominator is not in factored form, so I want to factor it. That's a difference of perfect squares, which is x plus 2 times x minus 2. Now I have factored form, and I have standard form. So I can first identify my wholes. Do I have any common factors? No. No wholes. X-intercept occurs when the numerator is 0. If I solve the numerator, I get x equals 9. So that's at 9, 0. Vertical asymptote occurs where the factors of the denominator go to 0. So this time I have two vertical asymptotes. I have one at x equals -2 and one at x equals 2. That means I'm dividing my graph into 3 pieces. Horizontal asymptote. Because the degree of the numerator is less than the degree of the denominator, my horizontal asymptote is at y equals 0. My y-intercept is at -9/4 or -2.25. It's okay with that. Does it cross? So if my horizontal asymptote is at 0, I'm going to set 0 equal to 9 minus x over x squared minus 4 over 1, cross multiply. What am I actually finding here? 0 times x squared goes away to 0 equals 9 minus x. This says x equals 9. So does it cross my horizontal asymptote? Yes, at 9. But I actually already knew that because where was my horizontal asymptote? The x-axis. And so I was already just finding the x-intercepts. Right? So that's one of those odd cases. I already had found that out without having to find it now. If you have an x-intercept. There'll be some you don't have any x-intercepts though. That's right. So here my x-intercept is at 9. The constants. So what's the constant in the numerator? What's the number without a variable? That's what a constant is. Number without a variable. 9. What's the number without a variable in the denominator?
But that did not go down the right.
Huh?
Our y-intercept. Oh.
I just made it a decimal. It's negative 9/4. I just divided that. Because I know where negative 2.25 is a lot easier.
It's 9/4.
Thanks. I'm familiar with how fractions work. So 9/0, I have an I have a vertical asymptote at x equals 2, and I have a vertical asymptote at x equals -2. My horizontal asymptote is here. I know I have a y-intercept at negative 2.25. Okay. So there's only one section of this graph that I feel like I can graph right now. This has got 3 pieces. I feel best about graphing the middle piece because I have the y-intercept. So I know it has to cross here. Does it ever cross my horizontal asymptote between -2 and 2? No. So it can't go up here, right? So that means it has to be tending towards that vertical asymptote. And then on the left side, can it go up here again? No. So it has to go down. So right here, between my vertical asymptotes, it has to have that shape. Now, did I have any togetherness of my vertical asymptotes? No. So that means if I go to the right, I can't start down here or I would have togetherness. So I have to start up here. Right? Are we following my logic? So I'm starting here. As I tend towards the asymptote, is it ever going to cross it? Yes. It's going to cross here. Then after it crosses, does it go down like crazy? No. What's it do once it goes across it? It just goes right back towards it. Right? It's going to tend towards that horizontal asymptote as the x's get really big. And then same story on the left. It can't be down here because I don't have togetherness. So it has to be up here.
And it does not cross.
It does not cross.
Does it not cross because we don't have an x-intercept?
Correct. And because I didn't find another place that it crossed. So if I don't find it crosses there, it can't cross.